Hey guys, today we're going to be learning about angles and radians. So let's start with some vocabulary. First of all, a ray is a part of a line that has only one endpoint and extends forever in the opposite direction. And that's actually what creates angles. Angles are formed by two rays with a common endpoint. And that common endpoint is called the vertex of the angle. So if we look here at this diagram, this point right here, this is your vertex. And both parts here, these are the rays that create the angle. An angle is said to be in standard position if the vertex is at the origin, which you can see here it is, and its initial side lies along the positive x-axis. So all of our angles that we're going to be looking at today are going to be put in standard position. So where your angle first opens up, this is the starting point of the angle, which is the initial side. And then where it opens up, and it ends up, that's the terminal side. So this is the end point of your angle. Now there are two types of angles. We have either a positive angle or a negative angle. A positive angle is when it opens in the counterclockwise direction, so going towards the left. A negative angle is when it opens in the clockwise direction, so going towards the right here. Or rather, a positive angle is when it opens up, and a negative angle is when it opens down. Now, we're going to be looking at angles in standard position, and we need to know what quadrant that angle is going to lie. And that depends on the terminal side. So wherever your terminal side lands, that's the particular quadrant. So our quadrants go in the counterclockwise direction, starting with the top right at 1, 2, 3, and 4. Now let's look at a couple of angles. Here we're going to determine whether this is a positive angle or a negative angle. Then we're going to state what quadrant the angle lies in. So here, well, all of these angles are in standard position because the initial side is on the positive x-axis. Here we can see that the angle opened going down. So this is a negative angle. By the way, this is the symbol for an angle. Then, in terms of what quadrant it lies in, this is quadrant 1, 2, 3, and 4. Since the terminal side lands in quadrant 3, this is a quadrant 3 angle. This next angle here, it is opening going up, so this is a positive angle, and it lands in quadrant 2. Over here, this is also a positive angle because it's opening going up. And this lands in quadrant 1 since the terminal side is in quadrant 1. Now this particular angle here is a negative angle since it opens going down, but you see that it lands here in between two quadrants. That is called a quadrantal angle when it lands on any axis. So if it lands on the y-axis, whether the negative or the positive, or if it lands on the x-axis. Those are called quadrantal angles. Now so far, we have only looked at angles in terms of degrees, but there is another unit of measurement for angles, which are radians. So to figure out what a radian is, we're going to consider an arc length S on a circle of radius r. So here's a diagram so you can see. The measure of the central angle theta that intercepts the arc is defined by the following equation, S over r radians. So how to figure out what radians are, or what the radian measure is, you take the arc length of the angle. So the intercepted arc, or the arc length they're talking about, is this. Because if this is the angle, then the arc that they're talking about is within that angle. So that's S, and you divide it by the radius, and that's going to give you the angle measure in radians. So let's look at how to find radian measure when you're given the arc length and the radius. Here it says, a central angle theta in a circle of radius 6 inches intercepts an arc length of 15 inches. What is the radian measure of the angle? So radians is going to equal to the arc length, which is the 15 inches, divided by the radius, which is 6 inches. When we divide, the inches cancel out, and we're left with 15 divided by 6, which is 2.5. Now, as I wrote here, when you divide, you will see that your units will cancel, leaving you with a number with no units. Radians are considered the invisible unit. You can write radians if you'd like, but it would only be for emphasis. So basically, if you divide the arc length by the radius and you cancel out your units, what you're left with are radians. Now, we don't typically need to write down radians, but if you feel more comfortable, you like to define your units, you definitely can. But just so you know, that's why radians are considered the invisible unit. Now, let's look at this next example. A central angle theta in a circle of radius 144 inches intercepts an arc length of 42 feet. What is the radian measure of the angle? In order to figure out the radian measure, we need to divide the arc length, which is 42 feet, by the radius, which is 144 inches. You'll notice here that my units do not cancel because these are completely different units. So I would need to convert one or the other. You can either convert the feet to inches or convert the inches to feet. That's up to you. I'm going to choose to convert the inches to feet. In order to cancel out inches, I would need to have inches in the numerator. There are 12 inches in 1 foot. So this is how I would do my conversions. That way, inches are in a diagonal, so when we multiply, the inches would cancel and the feet would cancel. So what we have here is 42 times 12 divided by 144. Now you can just multiply and then divide, get your answer. You can also simplify the 12 and the 144. 12 divided by 12 is 1, and 144 divided by 12 is 12. And then you can just divide now 42 over 12, which gives you 3.5. So the angle measure would be 3.5 radians. And again, just in case, I don't need to write the radians, but I'm doing so just for emphasis. Now let's look at what is the relationship between degrees and radians. So first, what we have here is a circle. Now what we know about the circumference of a full circle is that the circumference is 2 pi r. In order to determine the relationship between an angle measure in degrees and radians, we think about finding the radian measure of a full circle. The arc length of a full circle is the circumference, which is 2 pi r. And then we divide by the radius. So when we divide by the radius is here in the numerator and in the denominator will cancel, and we're left with 2 pi. So what does this mean? This means that one full rotation, which is 360 degrees, is going to equal to 2 pi radians. So if I wanted to come up with a conversion, that means that 360 is equal to 2 pi. And I can actually simplify this a little bit, and I could divide 2 to both sides. And I get that 180 degrees is equal to pi radians. This is going to be the relationship that I'm going to use to be able to convert from degrees to radians. So let's look at how to do that. If you're going from degrees to radians, in order to convert, you are going to multiply the degrees by pi radians over 180. In order to convert from radians to degrees, we are going to multiply the radians by 180 degrees over pi. Now, why do we do this? Let's look at an example so I can explain. We have here 90 degrees, and we want to convert this to radians. So what we need to do, since we're going from degrees to radians, we're going to multiply by pi over 180. What happens now is that the degrees will end up canceling. and I end up with only radians left. So this is going to equal to 90 pi over 180. Now when it comes to radians, we want to leave our radian measure with pi. So we're not going to actually multiply and get a decimal like we did in the previous examples. Here we're going to keep our angles with the pi and just simplify the fraction. So I can cancel out these zeros, and then 9 over 18 can be simplified by 9, which gives you 9 divided by 9, 1, so 1 pi, over 18 divided by 9, which is 2. So 90 degrees is equivalent to pi over 2 radians. Let's look at another degree measure. We have negative 135 degrees. Now the actual negative is not going to do anything to our angle. Remember that a negative angle just indicates the direction in which the angle is opening. This means that the angle is opening going down. So I'm going to go ahead and multiply by pi over 180. Again, the degrees will cancel, so I'm left with only radians. And so we end up with negative 135 pi over 180. And now we'll need to simplify. Now you can simplify this angle. Both 135 and 180 can be divisible by 45. So negative 135 divided by 45 is negative 3 pi. And 180 divided by 45 is 4. So this would be my radian measure. Now let's look at how we would go from radians to degrees. Here is my radian measure, and I am going to now multiply by 180 degrees over pi. What happens here is now the pi's will cancel, so radians are gone, and I'm left with degrees. So again, this is a negative angle, but remember that negative just carries on to our angle, it just tells us direction. So this is what I like to do in terms of simplifying to make it easier and you don't have to use a calculator all the time. We have here negative 5 times 180 over 6. 180 can be divided by 6 because 18 over 6 is 3 and then you got the 0. So 180 divided by 6 gives you 30. So now what I multiply is negative 5 times 30, which is negative 150 degrees. Let's try that again. Here we have pi over 4. I'm going to convert this to degrees by multiplying 180 over pi. My pi's will cancel, so I'm left with degrees. So this gives me 180 degrees divided by 4. And 180 divided by 4 is 45. So pi over 4 is equivalent to 45 degrees. Now that we have established what degrees and radians are, let's look at how to draw our angles in standard position. So first of all, we want to draw and label the angle theta, which is equal to pi over 4. I have here some steps for you to follow. First, we're going to place the vertex at the origin and the initial side on the positive x-axis. Then you're going to divide the angle by 2 pi, or multiply by 1 over 2 pi, which is the same as dividing 2 pi, to find the fraction of a revolution. So let me explain what this means. A whole revolution is 2 pi. So if I take my angle and I divide it by 2 pi, that tells me exactly how far I need to open. So let's look at how that works. We take the pi over 4, and we're going to multiply by 1 over 2 pi. Now again, we're just going to simplify this fraction. The pi's will cancel, and I'm left with 1 over 8. This means that the angle is 1/8 of a revolution. So what I do now is I look at the denominator, and that tells me how to break up my quadrants. So I'm going to do that in a separate color here. So I want to evenly divide my coordinate plane here into 8 parts. So we have this, and this, which divides it into 4. Then I can divide each quadrant by 2, and that gives me 8 equal parts. So see, 1, 2, 3, 4, 5, 6, 7, 8. So that is my 8 parts. The angle is only 1/8 of a revolution. So that means that from my initial point here, I'm going to open, the numerator tells you to what part to go to. So it's only 1, so I go to the first line. So this is my angle here, pi over 4. So that's why here for 3 and 4, it says to divide the grid evenly by the number in the denominator. From the x-axis, you count your way around the origin until you reach the number in the numerator. This is where the angle's terminal side lies. So again, I divided my quadrant here into 8 parts. Then my numerator is 1, so I counted up 1 to the first line. So let's try that again. We're going to work with these angles, and we're going to keep these all in radians. So first we have here theta, which is equal to 4 pi over 3. So I need to figure out what fraction of a revolution I have so that way I can figure out how to divide my quadrant. So I'm going to multiply by 1 over 2 pi. The pi's will cancel, and I have 4 over 6 revolution, which can be simplified to 2/3 of a revolution. Now I want to divide my axis here into 3 equal parts. When I try to divide into 3, that's kind of difficult to do, especially since my first part has to be here at the positive x-axis, since that's where my angle starts. In order to divide it into 3 parts, think of a peace sign turned sideways. It would look something like here and here. And these would be our 3 equal parts. So now to draw the angle, we've already divided into the 3, which is a denominator. My angle must be from the vertex and in the starting position here on the positive x-axis. And then it's going to open 2 times. So I'm going to come here, this is 1 and 2. So this will be my terminal side of the angle. This would be our theta. Let's try this next one. We have negative 5 pi over 6. So I want to figure out what's the fraction of a revolution. So I'm going to multiply by 1 over 2 pi. And when I multiply, what I end up with is the pi's will cancel, so I get negative 5/12 of a revolution. Really, it's 5/12 of a revolution, but the negative tells me the direction in which to open. So again, the denominator tells me how many parts I need to divide my quadrant. It's 12. So that means that I can start off by dividing each here by 4. And then if I divide each quadrant into 3 equal parts, I would end up with 12 in total. So I can start off by 1 line here. Now these don't necessarily have to be 100% exact. We are trying to get more or less a picture of where my angle will lie. So these are my 12 parts. See, if I'm starting here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have our 12 parts. Now we're ready to draw our angle. So again, our angle has to start in the standard position. It is a negative angle, so I'm going to open first going down. And I'm going to go to the 5th line. So here's 1, 2, 3, 4, and 5. So this is my angle, negative 5 pi over 6. Now let's look at this last one here. We have 15 pi over 6. So I'm going to multiply by 1 over 2 pi. My pi's will cancel. and I get 15 over 12, which can be simplified by 3, so 5 over 4. So that is 5/4 of a revolution. So let's draw this out. First, I have to divide my quadrant into 4 equal parts. So that's just my axis. Now let's work on putting our angle. We're going to start here at the vertex and in standard position. And I'm going to open 5 times around. Now 5 is more than 4, which is 1 full revolution. So that means that this angle does more than 1 full revolution. So here we go. We have 1, 2, 3, 4, and 5. So my angle would land right here on the axis. So this is an example of a quadrantal angle. So this would be your angle 15 pi over 6. Now, as you notice here, angles can go around and revolve as many times as possible. Since an angle opens circularly, a circle can go on forever and ever and ever. So that leads me to the next topic, which are coterminal angles. Two angles with the same initial and terminal sides, but possibly different rotations, those are called coterminal angles. Every angle has infinitely many coterminal angles, and this is because of what we saw in the previous example. We saw that the angle can go more than 1 full revolution, as well as going backwards. So let's look at this particular angle here. We have this angle. Now, if I open in the positive direction, that is the 130. However, if I open in the negative direction, I end up with the same exact angle. So I would need to figure out what is that coterminal angle. In order to figure that out, a full rotation is 360. So what we can do is we can subtract 360 to get that negative coterminal angle, which 130 minus 360 is negative 230. So this angle is negative 230 degrees. If you wanted to find another positive coterminal angle, then you would take the 130 and add 360, because then that would mean that you have the 130 plus a full revolution, which would give you the coterminal angle. And again, you can keep adding, you can keep subtracting, and you would end up with many, many coterminal angles. Now in this question, it says, what do you think you would do if you were given an angle in radians? So in order to find a coterminal angle, you are adding or subtracting 360 degrees. But if it's given in radians, a full revolution is 2 pi. So instead, you would either add or subtract 1 full revolution, which is 2 pi. So that's how you would find a coterminal angle if it was given in radians. So let's practice just that, finding our coterminal angles. Assume the following angles are in standard position. Find a positive angle less than 360 or 2 pi. So that's going to be for the positive. We want it to be less than 360 or 2 pi. And a negative angle that is coterminal to each of the following angles. So, like I said earlier, coterminal angles can be found by adding or subtracting 360 or 2 pi to the given angle. So first, let's find a positive coterminal angle for 820. Now, 820 is more than 360. So if I want a coterminal angle that is positive but less than 360, I would have to subtract 360, which 820 minus 360 is 460. But 460 is still more than 360. So I'm going to subtract 360 again. And what I end up with is 100. So this is a positive coterminal angle that is less than 360 degrees. To get a negative coterminal angle, we take the 100 and we're going to continue subtracting until I get a negative. 100 minus 360 is negative 260. So a negative coterminal angle would be negative 260 degrees. Now here we want to find a positive and negative coterminal angle to negative 135. In order to find the positive coterminal angle, because this is negative, we're going to add 360. And negative 135 plus 360 is 225. So that would be my positive coterminal angle. To get another negative coterminal angle, since this is negative, it's already a negative angle, but to get a negative coterminal, I would have to continue to subtract 360. Negative 135 minus 360 is negative 495. So that would be the negative coterminal angle. Now let's look at when we shift over to radians. Here we have 17 pi over 6. Now I want a positive coterminal angle that is less than 2 pi as the instructions indicate. But I need to figure out if 17 pi over 6 is already more than 2 pi or if it's less than 2 pi. So what we're going to do is we're going to get 2 pi and we need a common denominator, which would be 6. So I put 2 pi over 6 and I'm going to have to multiply the numerator by 6, which is 12 pi over 6. So 12 pi over 6 is 2 pi, because 12 divided by 6 is 2. Now 12 pi is less than 17 pi over 6. So if I want a coterminal angle that is positive but less than 2 pi, I'm going to have to subtract 2 pi, which is 12 pi over 6. When we subtract 17 pi minus 12 pi, I get 5 pi over 6. Now to get a negative coterminal angle, I can take that 5 pi over 6 and subtract another 2 pi, the 12 pi over 6, which would give me negative 7 pi over 6. So that would be my negative coterminal angle. Now let's look at negative pi over 12. We want a positive coterminal angle. Since this is negative, I'm going to have to add 2 pi. So this is over 12. So first I need to convert 2 pi so that it has a denominator of 12. So I'm going to multiply the denominator by 12 and the numerator by 12, which gives me 24 pi over 12. So I'm going to add 2 pi, the 24 pi over 12, and that gives me 23 pi over 12. To get a negative coterminal angle, I can take my negative pi over 12 and subtract 2 pi, which is a 24 pi over 12. And I get negative 25 pi over 12 as my negative coterminal angle. Now, let's look at how to draw these coterminal angles. So what we want to do here is we want to identify a positive and negative angle that is coterminal to 45 degrees. Then we're going to draw each angle in standard position. So first step here, and I have the steps here for you, we're going to follow the steps given on drawing angles in standard position for the given angle. So we want to draw 45 degrees. Now in the previous examples, we were drawing only radians. So now we're going to look at how to draw an angle that's in degrees. I'm going to go back a second so you can see. When we were drawing our radians, we divided by or multiplied the reciprocal, but we essentially divided by a full revolution in radians, which is 2 pi. So here what we need to do is we take our angle, and since this is in degrees, we are going to divide by a full revolution in degrees, which is 360. So we want to figure out what fraction of a revolution is 45 out of 360. So instead of actually dividing, what we're going to do is find that fraction. 45 and 360 can be simplified by 45, which 45 divided by 45 is 1, and 360 divided by 45 is 8. So this is 1/8 of a revolution. So I'm going to divide my grid here into 8 equal parts. So here's my 4, and then I divide each one in 2. Oops, missed a little there. Now the 45 degrees, again, we're going to put our angle in standard position, and it is 1/8 of a revolution, so that means that it would land right here. So this is the 45 degrees. Now let's find a positive coterminal angle and a negative coterminal angle. To find a positive, we take the 45 degrees and we're going to add 360. When we add 360, we get 405 degrees. To find a negative coterminal angle, we take the 45 and we subtract the 360 to get a negative angle. And 45 minus 360 is negative 315 degrees. Now, how do we draw this out? Let's start with the positive, which is 405 degrees. So a positive coterminal angle means that it is the 45 degrees plus a full revolution. So it's going to end up in the same spot. So this that's in purple, again, it's going to look exactly the same. The angle position doesn't change. It's the rotations that change. So this is the 405 degrees. Now the negative coterminal angle means that it opens in the opposite direction. So I would start in standard position and then open in the other direction back to its terminal side. So this is the negative 315 degrees. So again, the actual angle never changes, it's just the rotations that change. So let's practice. So here we have a mixture of degrees and radians. And as I had put in red in the previous slide, if you are given radians, please keep your angles in radians. If you are given degrees, keep your angles in degrees when it comes to drawing these angles. So here we have 3 pi over 4. So we have radians. We're going to stick with radians. And I want to know what fraction of a revolution that's going to be. So I'm going to multiply by 1 over 2 pi to get the fraction of the revolution. Here, the pi's will cancel, and I'm left with 3 over 8. This is the revolutions. So I need to divide my quadrant here, or my quadrants, into 8 equal parts. So I'm going to cut this into 8 parts, which is just like the previous one. We have our 4, and then divide each quadrant here by 2. Now 3 pi over 4 is 3/8 of a revolution. So that means that we're going to start here in standard position and go 3 lines over. So 1, 2, 3. So my angle is here. And remember, my angle is not going to change. This is 3 pi over 4. Now we're going to find our coterminal angles. Let's start with the positive. In order to get a positive coterminal angle, that means I need to take 3 pi over 4 and add 2 pi. Which to add 2 pi, I need to put this over 4, meaning multiply the numerator by 4. And we get 3 pi over 4 plus 8 pi over 4. Which gives me a positive coterminal angle of 11 pi over 4. Now to draw that, that means that we did 3 pi over 4 plus a full revolution. So I end up back where I started. So this is the 11 pi over 4. Now let's do the negative coterminal angle. That means that I take my angle, the 3 pi over 4, and I'm going to subtract 2 pi, which I had already gotten to be 8 pi over 4. 3 pi over 4 minus 8 pi over 4 is negative 5 pi over 4. And remember, a negative angle just opens in the opposite direction. So this would be the negative angle, the negative 5 pi over 4. Now let's look at this negative 30 degrees. First, I need to figure out how many revolutions or what fraction of a revolution we have. Since this is in degrees, that means that I'm going to divide by 360. We can simplify this fraction by canceling out the zeros, and 3 over 36 can be divided by 3. So negative 3 divided by 3 is 1, and 36 divided by 3 is 12. So that means that negative 30 degrees is negative 1/12 of a revolution. So I'm going to cut my quadrants here into 12 equal parts. That means that I have my 4, and then I cut each quadrant in 3s. Again, this is not 100% exact, but you get the picture. So here's my 12 parts. Now let's draw that angle. So we're going to start in standard position. It's a negative angle, so that means that I'm going to go down to the first line. So this would be my negative 30 degrees. Now we're going to get a positive coterminal angle and a negative coterminal angle. So let's start with the positive. That means that I take my angle here, negative 30 degrees, and I'm going to add a full revolution, which is 360. And that's going to give me 330 degrees. So positive, that means that I open going towards up. 330 degrees, it's going to land right at the terminal end. So this is the 330. Now we're going to find a negative coterminal angle. So that means I take the negative 30 and I subtract the 360, which gives me negative 390 degrees. So this is a negative angle, so that means that I took my negative 30 degrees, and then I went around another revolution, so I come back to where I started. So this is the negative 390 degrees. Now, last one here, we have negative pi over 3. So we're back to radians, so I'm going to multiply by 1 over 2 pi. To get that fraction of a revolution. Cancel out the pi's, and I'm left with negative 1/6 of a revolution. Now, we saw in earlier when we were dividing into 3 equal parts that we did kind of like a peace sign. So it's this part here, and then here, and here. So this gives me 3. So that means now that I need 6. So I'm going to do the same pattern, but in the other side. So we have this line here, and then over here, and here. So here we have our 6 equal parts. So now let's draw this angle. This is negative 1/6 of a revolution. So we always start here in standard position. Negative 1/6, that means I'm going to go down 1. So this is my angle. This is the negative pi over 3. Now let's find a positive coterminal angle. So we're going to do negative pi over 3 plus 2 pi, which I have to put it over 3, meaning multiply the numerator by 3. So this gives me negative pi over 3 plus 6 pi over 3. Which when I add these together, negative pi plus 6 pi is 5 pi over 3. So my positive coterminal angle, that means I open up, and we always end up at the terminal side, so it's going to come here. So this is the 5 pi over 3. Now let's do the negative coterminal angle. So again, I'm going to take my negative pi over 3, and now I'm going to subtract 2 pi, which we got to be the 6 pi over 3. Negative pi minus 6 pi is negative 7 pi over 3. So this is a negative angle, and I did negative pi over 3 minus a full revolution. So I'm going to go back around and back to the terminal side. So that is negative 7 pi over 3. And that's drawing all of your coterminal angles.